when it comes to the topic colloids, we'll figure out that colloids is basically going to be a state of matter between what we call something as complete solution and what we call as a suspension. Now, suspension is more like a precipitate. Something completely soluble, could be of these two types. It's called crystalloids and colloids. And this bifurcation was given by this scientist, Thomas Graham. He came up with the nomenclature colloids based upon, whether it's going to pass through a animal membrane, plant membrane or not. So crystalloids is like sugar, salt, which is completely soluble in water, and they pass through both filter paper as well as what do you call the parchment membrane. Now, parchment membrane or parchment paper. At any point of time, if there's a problem in understanding, you can ask me. But these terms are going to be required: parchment paper or animal plant membrane. Whereas colloids, as I told you, is neither a precipitate nor a solution. It's neither completely soluble, but it's going to pass through. It's going to pass through. It's going to pass through filter paper. It's going to pass through filter paper, but not through a parchment paper, not through a parchment paper or an animal or plant membrane. So basically, I guess the broader picture will be you'll have something completely soluble, something a state between soluble and precipitate. And if I go about writing suspension, colloid, and solution, so crystalloids is a term which I wanted you to know, but solution, colloid, and a suspension, which is like a precipitate. The size of a colloid is typical between, the size is between 10 to 1000 angstrom. Naturally, keeping water as the medium, a solution will have a size of the particle less than 10 angstrom, whereas a suspension will typically have particles with size greater than 1000 angstrom. I hope you're able to copy it down. बच्चे लोग हाँ ना बोलते रहो. Solution is certainly which is invisible. It's completely invisible. So it's completely invisible. This will be visible using an advanced microscope. It's called an ultra microscope. Now, this is obviously visible to naked eye. This is visible to naked eye. It's like sand in water. And then I told you, hey, colloid is going to be a state of matter between solution and suspension. Suspension is like a precipitate. A filter paper, would help you in differentiating the two phase. Solution will pass through. I'm writing one more time. It will pass through both filter paper. It will pass through both filter paper and a particular membrane. I'll want to use this term again, which is parchment paper. Colloid will pass through filter paper, but not through a parchment paper, or it's going to be basically a membrane, and here this will pass. This won't pass. This won't pass. This won't pass through even filter paper. So this is like sand. This is like sand and water, which is certainly a precipitate kind of. Solution being completely invisible is going to be a completely, homogeneous medium. So it's completely homogeneous. This is certainly heterogeneous. It's like glue, starch. So a solution, is something where you'll not be able to see the solute particles. Here you'll see the solute particles, kind of floating in the medium. Suspension certainly is heterogeneous, completely heterogeneous. Homogeneous will mean it's going to be a clear solution. This will have particles floating in the medium, and this obviously would be like a precipitate. Now, what's floating in the medium is about what's floating is the dispersed phase, which is analogous to the solute, and the medium is called the dispersal phase, which is analogous to the solvent. So naturally, it's heterogeneous, and the two phases where the particles which are kind of neither settling down. See, if it settles down, it's a precipitate and is not completely soluble, will have two phases, a dispersed phase and a dispersal phase. Naturally, dispersed phase is the one, which is kind of floating. Dispersal phase is analogous to the solvent. If you have a question at any point of time, you can ask me. It's a state of matter. It's a state of matter. In the sense, you can have something as a solution converted to a colloid, or something as a precipitate also converted into a colloid. I hope my voice is loud and clear.
Yes.
It's a state of matter. It's not a class of compound. Colloid is not a class of compound. I told you it's a state of matter. It's a state of matter. It's not a class of compound. It's not a different class of compound. In the sense, I can give you an example. I can give you an example in the sense, NaCl is completely soluble. NaCl, something which is completely soluble, would be in a medium like benzene, colloidal. And then, you would have known some medicines which use gold, silver, particularly the Ayurvedic medicines. So even gold, silver can be broken down, Yeah, they're metals, they're certainly metals. They can be, broken down and can be converted to colloidal form. So something, which is an absolute soluble stuff in a medium like benzene could be colloidal, and something which obviously the metal is not going to dissolve in water, but if it's broken into very fine particles, it could be converted to a side where it will be in colloidal form. The form colloidal form will mean it's between precipitate and soluble. It's going to be suspended in the medium and would settle down, if centrifuge, that's a different story. And if you're happy with this, if you have noted it down, you understand it's not a different class of compound, it's a state of matter only, where the particle medium relationship is typically between 10 angstrom to 1000 angstrom, neither completely soluble nor completely precipitate. If you're happy with this, we'll want to move on. But chalo ghana bolo.
So,
So yes, we can move to the next frame. I think you have noted it down.
yes, sir.
Now, the two basic type of colloids are lyophilic and lyophobic. So yet again, lyophilic, solvent loving, you call it hydrophilic as well. Hydrophilic when water is the medium. They are solvent loving. They are solvent loving. And lyophilic, which is also called hydrophobic if water is the medium, is solvent or medium hating. Phobic, the word phobic means, there is a disliking. Philic means there is a lot of liking. So you have a lot of affinity between the two phases, the dispersed and the dispersal medium. And these are the so-called natural colloids, as I told you, like glue, starch, or gelatin. Please respond with a yes or no.
Yes.
They are naturally in the colloidal form. They're naturally in the colloidal form. So certainly, some compound going into water with natural colloidal form are going to be easy to precipitate, will be highly solvated or hydrated, considering water is the medium, will be easy to prepare and difficult to coagulate, will be reversible in nature. Reversibility is like if you add water, it will dissolve, and if you remove water by evaporation, you get back the dispersed phase. Whereas lyophilic, being artificial or synthetic in nature, would have special methods of preparation. We'll go into these methods one by one. Will be certainly less solvated or hydrated, will be more easily coagulated, would be so many times irreversible in the sense once you try to remove water or solvent, the tendency or the possibility of getting back a colloid will be gone. And because they are naturally colloidal, chances are hydrophilic or natural colloids are going to be neutral in the sense there is going to be no charge. Whereas so many times a hydrophobic colloid, lyophobic colloid, and the particles will contain positive, negative charges. See, one reason why it can stay in a colloidal form is, and please hear me out. If suppose they're containing charges, they'll repel, and because they'll repel, they'll never settle down. So that's another reason why you can have a colloidal form where because of positive negative charges, they'll repel, and obviously it's the repulsion between particles. They won't precipitate, but would stay floating in the medium. And that's another reason you can have a colloidal form. But more often than not, a lyophilic colloid will have no charge, they'll naturally be of that colloidal size, and a lyophobic colloid will have charge containing, particles. Yes, we can move on.
Just 1 second.
I'm sorry, I did a mistake here. Although I was writing it all right, but I might have done a small little mistake. It's not easy to precipitate. It's easy to prepare. I'm really sorry about it. I'm sorry about it. It's easy to prepare. It's easy to prepare. Matlab, when you have to prepare a lyophilic colloid, you just need to mix the two medium. You just need to mix the two medium, two phases rather. The medium, which will be the dispersion phase, and whatever is going to, be floating naturally. So
So,
here it's easy to prepare. Yes,
सर
please.
लायोफोबिक का लास्ट पॉइंट के नीचे में क्या है? रिपल्शन बिटवीन पार्टिकल्स.
Repulsion between particles, and that is why they won't precipitate. They'll not precipitate. The particles will repel among themselves and they'll never settle down. So you prepare a hydrophobic colloid so many times by imparting them charges. So if they're going to be having same charges, all the particles will have same charge. So naturally with same charge, they'll be repelling and they'll not coagulate. That could be an important idea behind the different principles used in preparation of colloid and at times destroying a colloid. So far so good, I believe. Just please.
Yes.
Now, when I told you about preparation of colloid, now all methods of preparation of colloid are obviously for the lyophobic one, because lyophilic colloids being naturally colloidal, uh, are formed simply by mixing the two phases. So all the methods of preparation which I take up are for lyophobic colloids. Now, naturally, the two common methods would be either a method called dispersion or a method called condensation. Now, dispersion would be, splitting bigger into smaller particles. Whereas certainly condensing means something which is kind of grown, which is kind of, aggregated. So this is when the particles are too small and they are aggregated to larger size. Now these are mechanical methods, where something would be either broken into smaller particles or something would be aggregated, from a smaller size to a larger size. A named process is Bredick's arc method. Just know this name. Bredick's arc method is electrodispersion. This is electrodispersion. So what happens in Bredick's arc method is, high voltage is kind of established between gold, silver, acting as electrodes. And electric arc, which means a very high voltage, is struck between metal electrodes. Now, what are these metal electrodes? They're generally gold, silver, platinum, underwater, and then the system is abruptly cooled. The system is abruptly cooled. So when a high potential is struck and an electric arc is struck between metal electrodes underwater, you use a stabilizer. Potassium hydroxide is a stabilizer. Using KOH is a stabilizer. You would want to write somewhere. KOH is used as a stabilizer. Some electrolyte is used as a stabilizer. and then the system is abruptly cooled by dropping it into immersing it into ice bath. What happens in the process is this electric arc being stuck between the metal electrodes, the metals vaporize, and on abrupt cooling they condense to colloidal form. The basic idea is you should know the name. Brady arc method is a method of preparation of colloid, generally metal colloid, which is an act of electrodispersion, where an electric arc is stuck between metal electrodes, and then the system is quickly, abruptly cooled by immersing into an ice bath. So initially the metals at high temperature, under electric current, the heat of the arc, the heat of the arc, the electric arc, this heat would melt the vapor and then vaporize it, and those vapors quickly condense to the colloidal form. You just need to know this method, know the name Brady arc method. And then another very important method, all of this is there in WBJ syllabus and other exams as well. You just need to be acquainted with these terms. Have you heard of peptidation? Peptidation. Now, this is going to be important. This is going to be important. Peptidation. Please note down the next term is peptidation. I hope it's pretty visible. Peptidation is going to be a very important method. Just a couple of statements. Now, what is peptidation? Peptidation is dispersion or conversion of freshly prepared precipitate. Please note it down. Freshly prepared precipitate into colloidal form by adding a suitable electrolyte. So in a nutshell, it's like a precipitate is converted to a colloid by adding an electrolyte. This is what I was talking about as a case of imparting charges. I hope you're noting it down. Now it's based on what's called preferential adsorption of ads. Suppose you have a precipitate of ferric hydroxide. You add a little bit of FeCl3 to it. Now what will happen is ferric hydroxide would take up ferric particles and they'll all gain some positive charge. Now this will become a positively charged colloid. Some of the precipitate particles, this is a precipitate, it's a precipitate, dark brown precipitate ferric hydroxide. You add a little FeCl3, the electrolyte which is added by the way, is called a peptiding agent. It's called a peptiding agent or a peptiding electrolyte. So I hope I'm being understood. Please hear me out. Well. There was some issue with the internet. Yes, we're back in action. You all can hear me loud and clear? You all can hear me loud and clear?
Yes.
ठीक है बच्चों लोग एक बार वापस रिकॉर्डिंग चालू करना पड़ेगा. So I think it was pretty visible, it was pretty understandable. I'm sorry, I think it was pretty understandable. Although I want to talk about peptidation one more time, I want to hear from you people if my voice is loud and clear now. There was some glitch in the internet. Now I think we're back in action. बच्चों लोग हाँ ना बोलो peptidation. I'm still waiting for somebody, to respond with a yes or no, and I'll move on. What
Yes.
is peptidation? All right. So peptidation, I repeat, is again going to be understood like an act of converting a precipitate to a colloid. This person of freshly prepared precipitate into colloidal form by adding an electrolyte. It's based on what's called adsorption of ions. I'll tell you why it's called preferential adsorption of ions. I'll tell you why it's called preferential adsorption of ions. Because it's going to common ion इसको adsorb करेगा. Ferrous hydroxide का precipitate है. FeCl3 डाल दिया उसको पेप्टाइजिंग एजेंट बोलते जो इलेक्ट्रोलाइट हम लोग डालते हैं. हर पार्टिकल के ऊपर में पॉजिटिव चार्ज आ जाएगा. अगर इसके ऊपर में Fe+3 लग गया, प्रेसिपिटेट में से कुछ पार्टिकल्स के ऊपर में Fe+3 अगर चिपक गया, फिजिकल एडसॉर्प्शन हो गया, तो पार्टिकल्स में पॉजिटिव चार्ज हो जाएगा. दे स्टार्ट रिपेलिंग एंड दे विल बी फ्लोटिंग इन द मीडियम. You add a little bit of HCl to AgCl, naturally Cl minus will be paid and it will form a negatively charged colloid. I think I'm being understood. बच्चों लोग हाँ ना बोलो.
Yes.
Silver iodide, silver bromide. अब silver nitrate plus Ki forming a precipitate of AgI. It's a very common piece of information that this is a precipitate. It's a precipitate, it's a very common piece of understanding. But please hear me out, it's going to be an interesting discussion. Couple of facts. Like, if AgNO3 is added to Ki, you understand AgI will be born in Ki. The medium will be, this is the medium to which AgNO3 is added. And here, I'll write AgI being formed in Ki will pick up I minus and it will form a negative colloid. It will be a precipitate, but some AgI particles will be suspended in water because Ki would give you some I minus. Whereas, if Ki is added to AgNO3, where suppose silver nitrate is the medium, you'll again have AgI precipitated, but this time AgI will pick Ag plus from silver nitrate and would form a positive colloid. I think I'm being understood. बच्चे लोग होना बोलो. Please respond with a yes or no.
लेकिन इसका लॉजिक क्या है?
क्या?
इसका लॉजिक नहीं समझ में क्यों?
इसका लॉजिक है adsorption. Is surface absorption. Adsorption is surface absorption. So many times you call it a precipitate, but you'll find some particles of the precipitate in the colloidal form. What is a colloidal form? Colloidal form is like, the particles are floating in the medium. They're not settling down. So I repeat, प्रेफरेंशियल एब्जॉर्प्शन का मतलब होता है हम लोग जिसको प्रेसिपिटेट बनाते हैं, जिसको प्रेसिपिटेट जानते हैं, उसका कुछ पार्टिकल्स कॉमन जो आयन होगा, मतलब AgI अगर है तो Pi में अगर बन रहा है तो वो I माइनस तक उस पार्टिकल्स को एब्जॉर्ब कर लेगा। आई एम नॉट सेइंग कि AgI का प्रेसिपिटेट नहीं होगा, but some particles, so it's not like when you precipitate AgI, you see a clear solution and AgI is a precipitate. So many times along with the precipitate, you'll find the system to be a little heterogeneous, blurry. Some particles, would be in the colloidal form as well. You can also do that by adding a bit of Ki to AgI precipitate, where this will be the peptiding agent. So, as I told you, the common ion would be taken up, वो precipitate से चिपक जाएगा, and if they're all similarly charged, same charge, similar charge, repulsion, and it would not precipitate, it would not settle down, and this is like preparation of a colloid by imparting some charge to the particle. The act of a precipitate becoming a colloid on deliberately adding a electrolyte is called peptidation. You're understanding me?
Yes.
And you need to know a few terms. I mean, that they're positive and negatively charged is obviously going to be proved, on applying an electric field. You'll find particles moving to cathode or anode, obviously depending on the charge. And they being moving to cathode or anode will mean they're carrying charge. And this entire act of the colloidal particles moving to cathode or anode and an electric field is called electrophoresis. This is called electrophoresis. If by using a particular medium, a particular membrane, if electrophoresis is prevented, the medium moves in opposite direction, and this is called electroosmosis. Now, this electroosmosis is the principle behind dialysis. People having renal failure, kidney failure. This electroosmosis is the principle behind dialysis. So you need to know these terms. Like when you look at the syllabus of WBJ, in the syllabus of WBJ, they want you to know the principle behind dialysis. Now, the principle of dialysis is based on electroosmosis. Obviously, neither I know nor I would want to tell you the medical aspect of how dialysis is done in case somebody has a kidney failure. But the idea remains the same, that the basic job of kidney is to remove the waste from the body, and it's based upon the idea of electrophoresis and electroosmosis. From the standpoint of colloids in chemistry, I would simply tell you that the lyophilic colloids carry no charge. Everything we're talking about is lyophobic colloids. They're colloidal because they carry positive or negative charge. You can prove it. It's also going to be an act of destroying a colloid. Electrophoresis is also an act of destroying the colloid. Because when you give them charge, they'll move to the cathode or not, depending they're positive or negatively charged. And, that's going to be an act of destroying the colloid, as I told you. If you prevent electrophoresis, you have a semi-permeable membrane kind of thing. The medium moves in opposite direction. That's the name and the case of electroosmosis. Applying an electric field, and discharging Discharging the charge is obviously an act of destroying the colloid, which could also be called as coagulation of colloid, precipitating the colloid. You can discharge the charge by carrying out electrophoresis, or you can discharge the charge by adding excess of an electrolyte. When you add an excess of an electrolyte, there's a difference between adding a little bit of electrolyte. When you add a little bit of electrolyte, it will form a colloid by picking some particles. But when you add excess of electrolyte, again, you'll be discharging the charge carried by the particles. And this act of adding excess of electrolyte and discharging the charge is called flocculation. I hope I'm spelling it all right. Now, flocculation is adding an excess of electrolyte again to kill the electrolyte, kill the colloid by neutralizing the charge. The ion which will be causing the coagulation will be called a flocculating ion. So a negative ion would be acting as flocculating ion for a positive colloid. A colloid is also called a SOL at times. SOL is another way of writing colloid, whereas a positive ion would be the flocculating ion for a negative SOL. More the charge over this ion, more is the flocculating power. So this is again a rule called Hardy-Sulz rule. This is called Hardy-Sulz rule. So if it's a negative colloid, some positive ions will be neutralizing the negative charge. If it's a positive colloid, some negative charges would be, discharging the charge. Hardy-Sulz rule and all, it was way back in the WB syllabus, even in oil and gas syllabus. It was a part of surface chemistry, even written in NCERT. Alum, way back in alum stopped bleeding because, blood is a colloid. So alum, you remember, would contain Al plus 3. More the charge over ion, more would be flocculating power because it will be able to discharge more anions with more positive charge. You remember this? You apply alum to, stop microscopic cuts. This is about discharging the charge over colloidal particles. This is Hardy-Sulz rule. So more charge, more effective in kind of coagulating. It's all about killing a colloid, discharging its charge by adding an excess of electrolyte. Remember, a small amount of electrolyte if added could convert a precipitate into a colloid. That's called peptidation. A large excess of an ion, would on the other hand kill a colloid. The last term will be interested in is gold number. Now, gold number is associated with an act of protecting a colloid from precipitating or coagulating. How do you protect a colloid? You understand, lyophilic colloids, please note it down, a couple of minutes more. Lyophilic colloids being more solvated or hydrated, if added to lyophobic colloid, can prevent its coagulation, can prevent its precipitation. Lyophilic colloids being extensively solvated can protect lyophobic colloids forming a layer around it. Gold number is the corresponding unit. Gold number is the corresponding unit. Again, there is something which you'll have to kind of remember. Number of milligrams of a lyophilic colloid. Number of milligrams of a lyophilic colloid required to just prevent the precipitate of a 10 ml of a gold salt, 10 ml of a gold salt on adding 1 ml of 10% NaCl solution, 1 ml of 10% NaCl solution. Is how you define gold number. This is the definition of gold number. So lesser the gold number, more is the protecting power. See, a very common question in the real exam is, they'll give you the gold number of different lyophilic colloids. First of all, you'll want to note like a story. See, everything which I've told you so far in colloids and would tell you later on in adsorption in surface chemistry has to be learned on a very superficial level and has to be understood like basic story in the sense I told you about lyophobic colloids carrying charge. Now, because they're carrying similar charges, they're suspended in the medium and floating. Colloid in simple terms. Now, this colloid, on adding an extra excess of an electrolyte, where the positive ion would kill the negative colloid and negative ion would kill the positive colloid, would get precipitated. That's flocculation. Now, another fact is, adding a lyophilic colloid, which is more solvated, to a lyophobic colloid can prevent its coagulation by forming a layer around it. And this protecting power is measured in terms of a unit which is called gold number. So it's very unlikely that you'll ever have to write this definition, but just for the sake of it, I kind of always remember it as 10 1 10 10 1 10. 10 ml gold soil में अगर 1 ml 10% NaCl solution डाला, so this NaCl would start, because generally a gold soil being a colloid charged particle, a positive colloid generally, NaCl would supply Cl minus, and this would start precipitating. And what they'll do is they'll give you the gold number of different lyophilic colloids, जिसका गोल्ड नंबर जितना कम होगा, जितना कम डालने से वो उसको प्रोटेक्ट कर सकता है. different lyophilic colloids, will have different protecting power. And the one which is required the least in milligram to just prevent, So this is the minimum amount of a colloid lyophilic, which can precipitate, it can prevent the precipitation of the soul. Is defined as gold number, and lesser the gold number, more is the protecting power. More the gold number, lesser is the protecting power. I don't exactly remember, but when I look into the real exam questions which have come in the recent past, I would tell you about a couple of colloids, lyophilic colloids, which have very low gold number. But the typical question is they'll give you the gold number of 4 particular colloids, and you just have to remember that the one having more gold number is a lesser protecting, and the one having less gold number will be more in protecting. So with this, we come to end of all the terms which we wanted to know for a topic like colloids. It all began with what's colloid? It's between a precipitate and something which is completely soluble. Lyophilic is glue, gelatin, starch, and the ones which are naturally colloidal. Lyophobic are generally formed by providing some charge to it, or they are either going to be broken into smaller particles or aggregated into bigger particles. You want to know a little bit about Brady-Stark method. You need to know a little bit about peptidation, electrophoresis, electroosmosis, finally flocculation and gold number. Now, two things which are there in the syllabus, but I would leave you to do a little bit of reading from some source is Tyndall effect and Brownian motion. So, you want to read about Brownian motion and Tyndall effect from some source, or maybe, a little bit about both the effects. Brownian motion, was observed by Robert Brown. And I don't know if I've told you or not, but this also went such a big way in the discovery of atom. A microbiologist polling grains in water, and with a microscope, he saw that they're randomly moving, and that motion is called Brownian motion. And this man came up with the idea that something which is being able to move microscopic particles with that particular haphazard manner would again be of microscopic size, and that is how the basic concept of atom being the smallest unit of matter was conceived for the first time. So Brownian motion is the motion which is carried out by particles which are suspended in a particular medium. Tyndall effect is how they would respond to visible light falling on a colloidal solution. So we want to read a little bit about both of them, at least know the definition and all. And with this, I'll conclude the session today. I'll see you, and the next time I meet you, we'll want to just finish it off with absorption. Also, I've given you the notes on absorption. I'll want to do this basic discussion one more time. And once we're done with all of it, tomorrow I'm traveling a bit. Tomorrow I won't be available. More on physical chemistry and organic chemistry, along with problem solving. एक बार छोटा टॉपिक हो जाएगा ना, रियल एग्जाम क्वेश्चंस देख लूंगा मैं, एक बार WPGA का भी प्रीवियस क्वेश्चंस देख लेता हूँ, तुम लोग भी देख लोगे, टॉपिक वाइज अवेलेबल है. The overall idea is you don't miss out on even a small little question on a topic which just needs a basic acquaintance. So this much for the time being. Stay happy, stay healthy. Thanks for joining. मिलते हैं बच्चे लोग. Take care. Bye bye.
Bye.